Good day, Dr. Asno. This is EEE3402, Industrial Control Electronics. I am James T. Chowsing, matrix number 185391.
My name is Aida Natasha Lin Ismail and my matric number is 182160.
I am Muhammad Hafiz bin Muhammad Yunus. My matric number is 183095.
In this video presentation, we are going to talk about the washing machine control system. And in this video, we will start off with our introduction to the washing machine, followed by the operation of the washing machine, and then we will show the ladder diagram of the operation of the washing machine, and we will close our presentation with the conclusion.
Okay, I will start with introduction. Basically, a washing machine is a device used to wash laundry, and water is used as a medium to remove all the spot and stain from the fabric. And here is type of washing machine. There are three types. The first is semi-automatic, second fully automatic, and third is fuzzy control. Features available in modern consumer washing machine. There are four of it. The first is delay execution, second is predefined programs, third is rotation speed setting, and fourth is variable temperature. And this is the part of washing machine. And as you can see, there is timer. The timer function as the time for the action in the washing machine. And as you can see, there is water pump where it pumps the water into the washing machine. And you can also see the agitator inside, where it used to spin the inside of the clothes in the washing machine. And another one is water inlet valve. It's let the water from the outside to enter the washing machine.
Next will be the operation of the washing machine. The operation will start by loading the clothes into the washing machine, and then it will measure the weight of the clothes loaded, whether it is below 3 kilograms, between 3 to 5 kilograms, or above 5 kilograms. Over here, the washing machine will decide the time of the operation of the entire process. After that, after deciding the time of the operation, the water will start flowing into the washing machine, and washing process will take place, followed by the rinsing process, and lastly the spinning process before the alarm will trigger to indicate that the entire process is done. And next, this is the block diagram of an open loop system. A washing machine is an open loop system because there is no feedback signal to the system. Whenever a set point is given into the controller, or controller can be said as the brain of the entire system, the controller will send an input signal to the actuator. Actuator will do all the process before giving out the output. Any disturbance to the system will not stop the process because there is no feedback to the system, so the system will not entertain, or I can say the system will not process the disturbance exist in the system. This is the block diagram of a washing machine. As I explained earlier in the flow chart, the input, which is the load size, will goes into the controller, then the controller will give out the time of operation, and then followed by the washing machine will do the washing process, followed by rinsing process, spinning process, and lastly it will give out the output, and the output is regardless of the cleanliness of the clothes because there is no feedback. The washing machine will not decide whether the clothes are clean or unclean, because whenever the clothes are given into the washing machine will do whatever process it can do, like washing, rinsing and spinning, and lastly it will give out the output, which is regardless of the cleanliness. And next, what is a fuzzy logic controller? Previously, I've explained on the block diagram, given that the input is fed into the controller. But what does a fuzzy logic controller does? A fuzzy logic controller intimates human deductive thinking, and it can handle problems that cannot be represented by a mathematical model. And a fuzzy logic controller improves development time and implementation cycle. In short, a fuzzy logic controller can think like a human. For example, if we see the sky is dark now, so we will say, oh, it is going to rain. Or when we see the sun out there is very hot, so we say, oh, looks like it's not going to rain, and the temperature out there is high. So it is the logical thinking of a human, just like what is applied to the washing machine. Whenever the clothes are given into the washing machine, the controller will measure the weight of the cloth, and it will give out the operation time of the entire process. So you can say, for example, clothes that are below 3 kilograms will give out the operation time of 150 seconds, for example. So it will decide itself, and operator does not need to decide how much time does the washing machine need to do the entire process. And followed by this, we will present to you the ladder diagram of the washing machine.
So next, we will proceed to the programmable logic controller of the washing machine through the i3Logy software. So basically, this is the overall operation for the washing machine. For the first part, which is the starting part of the washing machine, the start switch is connected to the normally closed top with output relay run. This rung will control the on-off of the entire system. The deactivation of stop button will cause the first rung to be open circuit, and thus the run relay connected at the output is deactivated, consequently cause the deactivation of the entire system. For the second part, which is the insert load part, that consists of input sensors. Basically, these input sensors are needed to determine the size of the load. For example, by loading the small size load, which is lesser than 3 kilograms, into the washing machine, the small load sensor will be activated, thus activating the on small load relay. Next part is the operation of filling water into the washing machine right after the size of the load is determined. The activation of on small load relay triggers the activation of on water small relay that is connected in parallel to the small timer. The small timer is set to 30 seconds. After 30 seconds, the small timer is activated. Next part is water stop, indicating the machine are ready for washing operation. The activation of on water small relay will trigger the water in output. The relay is connected in series to a normally closed water stop, so that when water stop is activated, water in will be deactivated. The water will then stop flowing into the washing machine. The small timer that was previously triggered is connected to the water stop output. In this step, water is filled into the washing machine for 30 seconds before it stops. Next part is the washing operation where the motor rotates in clockwise direction. Small timer that was previously activated is connected to the on motor output, which is in parallel with delay 1 timer. The activation of small timer will trigger the on motor output. Function of this on motor is to trigger the machine before it starts to rotate. Thus, on motor will be activated at the same time the activation of water stop. Motor will be triggered for 5 seconds before it starts to rotate clockwise. The delay 1 timer is connected to the counter 1 so that the activation of delay 1 will trigger counter 1, causing the on motor to be deactivated. The activation of counter 1 will trigger the 150-second timer to start counting, and the machine starts to wash. The activation of on motor will trigger the CW output, which refers to the clockwise rotation of the motor. For the rotation of the motor in counterclockwise direction, the activation of CW output triggers counter 2 to be switched on, thus activating the normally closed CW, preventing the activation of CCW output, which refers to the counterclockwise rotation of the motor. Counter 2 is connected in parallel with timer 1, which allows the counter to be activated within the time set in timer 1, which is 10 seconds. After 10 seconds of motor rotating in clockwise direction, CW output is deactivated, and this allows the CCW output to be triggered. This CW and CCW keep switching until the washing time ends. Next part is to drain the water out of the machine and fill in clean water for rinsing process. 150-second timer is connected to the W out small relay output that is in parallel with small out timer, which is set to 30 seconds. W out small relay is referred to as water draining out for small load. This relay is triggered once the 150-second timer is activated. This activation will next trigger W out output, which refers to the process of draining the water out of the washing machine. Duration of draining the water out of the washing machine is determined by the size of the load. After 30 seconds, small out is activated, and this trigger W in small that is connected in parallel with the small in timer, which is set for 30 seconds. The activation of W in small relay triggers the W in output, which refers to as the entering of clean water into the washing machine. Next, we proceed with rinsing process part. The activation of small in timer will trigger the disable water in water out relay that is connected in parallel to the rinse time. The activation of disable water in water out relay triggers the activation of rinsing process. Disable water in water out refers to the disable water in and water out function that stop both flowing of water into and out of the washing machine when the rinsing process is activated. The activation of disable water in water out triggers the rinsing process that lasts for 100 seconds, which is the time set in rinse time. After 100 seconds, rinse time is activated. The normally closed rinse time is open. The rinsing process stops, and at the same time, enable small rinse relay is activated. Enable small rinse is connected in parallel with small rinse water timer that was set for 30 seconds. The activation of enable small rinse relay triggers small rinse output. The water from rinsing process is drained out of the washing machine. The activation of small rinse water will trigger delay spin timer that is set for 10 seconds. The delay is to allow the operation to stop for 10 seconds before continue with spinning process. After 10 seconds, the delay spin is activated and triggers disable water rinse, which is connected in parallel with spin time. The disable water rinse is connected in series with normally closed spin time. The activation of disable water rinse triggers the spinning process. Spin time is set to 100 seconds. After 100 seconds, spin time is activated. The normally closed spin time is open, cause the spinning process to stop. At the same time, the activation of spin time triggers the alarm to on for 20 seconds, indicates that the whole operation is done. So for the conclusion of our presentation, a washing machine is an open loop system where the output, cleanliness of the cloth is not measured by the system. The controller that is done by the fuzzy logic controller determines the time required for the entire operation by measuring the size of the load. So we have clearly explained the operation of washing machine, and we come to the end of the presentation. That's all. Thank you.